There is a place on Earth so remote that the closest humans are often not on land, but aboard the International Space Station orbiting hundreds of kilometers above. This location is known as Point Nemo, the most isolated place on the planet. It is where space agencies send spacecraft to die, and the full story of this empty ocean is far stranger than you would expect. Point Nemo is not a legend or a rumor passed between sailors. It is a real, precisely defined spot on our planet, a mathematical answer to a simple but profound question. Where in the world's oceans can you stand, or rather, float, and be farther from land than anywhere else on Earth? This location is known to geographers as the oceanic pole of inaccessibility. Unlike the North or South Pole, which are defined by lines of latitude, this pole is determined by distance, specifically by being the farthest possible point from any coastline. The concept is straightforward but extraordinary. If you could draw a circle with the largest possible radius that fits entirely within the ocean, the center of that circle would be Point Nemo. Every direction from this point leads to open water for thousands of kilometers. There are no islands on the horizon, no ships passing by, no harbors or outposts, just the endless sweep of the South Pacific. This is not a vague region, but a single, calculated point, recognized by scientists and mapped with modern geodesy. Point Nemo stands as the ultimate symbol of remoteness, a place so far from land that it exists more as a mathematical idea than a destination anyone could stumble upon by chance. At 48 degrees, 52.6 minutes south, 123 degrees, 23.6 minutes west, a set of numbers pins the most isolated place on Earth to a precise spot in the South Pacific. This coordinate, known as Point Nemo, lies deep within the vast blue, far from any continent or inhabited island. What sets this location apart is not just its position, but its unique relationship to the rest of the planet. It is equally distant from three remote outposts of land. Ducie Island, a speck belonging to the Pitcairn Islands, sits to the north. Motu Nui, part of Easter Island, lies to the northeast. Maher Island, an icy fragment off the coast of Antarctica, rests to the south. Each of these landmasses is about 2,688 kilometers away from Point Nemo, a distance that translates to roughly 1,450 nautical miles in every direction. No matter which way you travel from this point, the journey to solid ground is nearly the same. It is as if Point Nemo stands at the center of a giant triangle, with its corners marked by these three distant shores. The boundaries are not drawn by coastlines, but by mathematics, a solution to the question of absolute remoteness. The numbers themselves are stark. 2,688 kilometers is about the same as the distance from New York to Denver, or from Paris to Moscow. For a sailor adrift here, every route is a marathon through empty ocean. This geometric symmetry, measured and verified, makes Point Nemo the true oceanic pole of inaccessibility, a place defined not by what is present, but by the vast emptiness that surrounds it. In 1992, a Croatian-Canadian geodesist named Hrvoje Lukatela set out to answer a question that had lingered for decades. Where, on the surface of our planet, is the oceanic point farthest from any land? The challenge was more than just a curiosity. It was a mathematical puzzle that demanded a new approach. Earlier explorers had tried to estimate such locations by hand, tracing lines on maps and measuring rough distances. Lukatela, however, brought the power of computers and modern mathematics to the problem. He began by framing the search as a maximum of minimum distance problem. Imagine every point in the ocean, and for each point, measure the shortest path along the curve of the Earth, not a straight line, to the nearest coastline. The goal is to find the one spot where this minimum distance is the greatest anywhere on the globe. This is not a simple matter of drawing circles on a flat map. The Earth is a sphere, and the true measure of distance is the great circle arc, what a ship or plane would actually travel, bending across the planet's surface. Lucatilla's solution relied on several mathematical tools. He used trigonometry and three-dimensional vector algebra to calculate distances on the sphere, ensuring accuracy over thousands of kilometers. But the breakthrough came with the use of Voronoi-type geometry. In this method, every stretch of coastline defines a region where it is the nearest land, partitioning the world's oceans into a mosaic of zones. Where three of these zones meet, you have a candidate for the ocean's pole of inaccessibility. To make the method work, Lucatilla needed a detailed digital map of the world's coastlines. He fed this data into his algorithm, which systematically searched for the point that maximized the minimum great circle distance to land. The result was precise and reproducible. Anyone with the same coastline data and the right code could verify his answer. The coordinates he found, 48 degrees 52.6 minutes south, 123 degrees 23.6 minutes west, locked Point Nemo into the scientific record, not as a myth, but as a consequence of geometry and computation. This was not a guess or a legend, but the outcome of a rigorous, transparent process, one that could be repeated, checked, and trusted. Point Nemo sits deep within the South Pacific Gyre, a swirling system of currents that covers nearly 10% of the world's ocean surface. This gyre forms a vast, slow-moving loop, trapping water in its center and isolating it from the nutrient-rich flows that feed coastal life. Here, the ocean becomes a desert. The concentration of life-sustaining elements like nitrogen and phosphorus drops to some of the lowest levels measured anywhere on Earth. Primary productivity, the rate at which microscopic plants turn sunlight into energy, barely registers, averaging just 0.04 grams of carbon per square meter each day. The water is startlingly clear, stripped of the plankton that cloud most seas, and the emptiness extends in every direction. Human presence is almost as rare as marine life. According to global ship tracking data, fewer than 1/10 of a vessel passes through each 100 square kilometers of this region per day. In practical terms, days or even weeks can pass without a single ship crossing the gyre's center. Most commercial routes skirt the edges, and research expeditions are infrequent. The result is a place doubly removed by geography and by the relentless, isolating logic of ocean currents. Point Nemo's remoteness is not only a matter of distance, but of oceanic design, a vast zone where both nature and humanity are nearly absent. The waters surrounding Point Nemo serve an unexpected purpose, one that connects the emptiest part of our planet with the future of space travel. International space agencies, including NASA, Roscosmos, and the European Space Agency, have designated this region as the South Pacific Oceanic Uninhabited Area. The logic is straightforward. With no land for thousands of kilometers and almost no ship traffic, this is the safest place on Earth to aim falling spacecraft. When a space station or satellite reaches the end of its life, mission controllers execute a controlled deorbit burn, steering the object into a precise descent path. The goal is to time the maneuver so the craft enters the atmosphere over this remote patch of ocean, where any surviving fragments splash down within a calculated impact ellipse, often no more than 200 kilometers across. Controlled re-entry is all about risk management. Engineers calculate the burn so the spacecraft breaks up at about 75 kilometers above the surface, with debris landing far from any human presence. This approach minimizes the chance of injury or property damage to nearly zero. Not every re-entry can be controlled. When a spacecraft loses contact or runs out of fuel, it can descend unpredictably. In 2001, the Russian space station Mir, weighing 130 tons, was brought down intentionally over the South Pacific, its final fragments scattering near Fiji. In contrast, China's Tiangong-1 laboratory re-entered in 2018 after its orbit decayed naturally. Even though its descent was uncontrolled, the debris still ended up in the same vast, uninhabited corridor. Each event demonstrates how this distant ocean has become a planetary safety valve, a place where the risks of space exploration are quietly managed, far from civilization. Legends cling to remote places, and Point Nemo is no exception. Internet forums and horror fiction often link it to Relaya, the sunken city from H.P. Lovecraft's mythos. But the coordinates do not quite match. Relaya's fictional site lies about 100 kilometers away. Stories of lost ships, sea monsters, and secret portals swirl through online threads, adding layers of drama to a place defined by absence. Yet, there are no vanished fleets or supernatural anomalies recorded here, just the rare passage of a racing yacht or a falling satellite. The myths thrive because the emptiness itself feels uncanny. In reality, Point Nemo's claim to fame rests on mathematics and measurement, not on the supernatural. Its mystery is rooted in the sheer fact of its remoteness, a quality that needs no embellishment. In a world mapped by satellites and crossed by signals, here lies a place so distant that no life endures, and no nation claims it. Point Nemo reminds us that Earth still holds true frontiers. Even now, mystery survives beyond our reach. Let that vastness spark your sense of wonder